My goal is to explain to you the review, and these are problems that you're going to see on the test. For number 1, it says approximate all points of relative extrema of each function, then approximate the open intervals where each function is increasing and decreasing. So we have these 2 points right here, and I'm going to kind of estimate, might have to make this bigger, might have to make this picture bigger, and I'm going to go ahead and do that right now. So just go ahead and we'll do this again. Use red. Okay. So this point and this point are our relative mins, our absolute mins actually. Those are our absolute mins, and this is our absolute, our local max. So I'm going to write that down. Relative minimum. So we have 1, actually it's like 1.5 or 1.4, comma, -5. And then the other one is -1.4, comma, -5. That's our relative min. Our relative max is going to be 0, comma, -1. Now you do notice that it's decreasing right here. So we're going to go ahead and write the interval for that. It's decreasing right there, and it's also decreasing right here. Okay, so let me go ahead and write the interval. Remember that the interval will be open, the endpoints. So we're going to go ahead and write down decreasing. So decreasing will be from -infinity up to -1.4 parentheses. And it's also decreasing starting at 0, and it stops decreasing at 1.4. Okay, so we've done relative min, relative max, and decreasing. Now we got to do increasing. And we notice in increasing, it starts increasing at -1.4, and it stops increasing at 0. So it's -1.4, and it stops increasing at 0. And then it starts increasing again at 1.4 right here, and it goes on to infinity. That Greek part is increasing, and it stops right there. And then it picks up again up here, and it's increasing. So that green part is increasing. The decreasing part is the actual blue part that's right here. So we notice that the following x values. So I went ahead and colored the intervals. And you notice you have vertical lines, and those vertical lines indicate the interval. And you notice that if we go in this direction, this is -infinity. If we go in this direction, it's positive infinity. And here is 0. And here is 2, right? So you kind of can see the interval. You see the yellow part for this first part that's increasing. It's increasing from -infinity, parentheses. You see -infinity all the way up to 0. And then you have parentheses because you don't include You don't include 0 because it's in transition. Now that red part, that red area, it's decreasing, so we're not going to worry about that right now. And then we pick it up again at 2. Remember, we use union to describe the two intervals, and then we have 2 to infinity. That's increasing. Decreasing, the only part that was decreasing was, like we said, the interval from 0 to 2. Okay, from 0 to 2. So that's our increasing interval, that's our decreasing interval. Now we need our local max. Now we're talking about order pair. Our local max is going to be 0, 6. Our local min is going to be 2, 2, 2. For number 6, we have this graph, and once again, we are going to find our increasing level, increasing interval. We're also going to try to find our decreasing level, our interval. And we don't have a constant here. I'm going to go ahead and use a highlighter to indicate our increasing part. So I'm going to use yellow to indicate the increasing. It's increasing here. It's also increasing here. Decreasing, we have decreasing right there, and then we also have decreasing right here. Remember that we're going to use the infinity sign to indicate as we go to the left, and as we go to the right, it's infinity signs. Okay. If you can look at the yellow part, as we did before, I have a broken line that goes through the relative max here. And that's going to help us to indicate what's our first interval. That's -1. So we notice that it's increasing from negative infinity up to -1. So it's increasing from negative, and we're always going from left to right. Negative infinity up to -1. That is not the only part that it's increasing. It's also increasing from, remember we're looking at the x value. It's increasing from 0 up to, it's increasing to 1. So 0 to 1. And to describe these two intervals together, we're going to say union. Okay. So we have also this vertical line. We have this vertical line. We have this vertical line. And we also have this vertical line. So it's broken up into regions, and you can kind of see the region that way. You can see how it's broken up. And if you look at the first region, that's increasing. This is the one I'm talking about. And then also here, you're seeing that it's increasing. So now we need the interval in which it's decreasing. So it's decreasing here. Where you see the D, it means it's decreasing, and here it's increasing. And it's increasing. So we're worried about the interval in which it's decreasing, and we notice that here at x equal -1, it starts to decrease. So we're going to write -1 comma right after -1, and it stops decreasing at 0. Now the next part, it's in transition, it goes up, and then once again at 1 it starts decreasing, and it decreases all the way to infinity. And to bring these two together, we're going to say union. Okay? So now we've got to find our local max and our local min. So our local max will be -1, comma 0. Another local max is going to be 1, comma 0. Actually, it will be absolute max since that's the highest point there. And then our local min is going to be 0, negative 1. 0, 0. So we have x, and you factor in x, so it's x minus 1. So your first possible answer is x equals 0. Your next possible answer is x minus 1 equals 0. So x equals 1. So we need to check. So we have f of 0 equals 0 squared plus 0, and that does give you 0. Okay. F of 1 is negative 1, 1 squared plus 1, and that does give you 0. So that checks. So your answer is C. For number 8, we're solving this quadratic equation, and we have negative x squared plus 7x minus 10 equals, remember we said it equal to 0. Since I don't want a negative as our leading coefficient, it helps with factoring. I'm going to multiply times negative 1, and we know that 0 times negative 1 is 0. So we're left with x squared. Negative 1 times negative is a positive. Negative 1 times 7x is negative 7x. Negative 1 times negative 10 is positive 10. The only reason I did that, I just don't want to work with that negative 1 as a leading coefficient. Okay, so now I have 10, and I'm going to do the factor sum method. So I need to get the factors of 10. Give me two numbers that you multiply that will give you 10. And we notice that negative 2 times negative 5 does give you positive 10. And then when you add negative 2 plus negative 5, you get negative 7. So what are the conditions that we want? We want it to be, these two factors have to multiply to give you 10. That's what we have for C. And then for B, that middle coefficient, we wanted to add it to be negative 7 and it. So we're going to go ahead and write it in factored form. So now we're going to have x minus 2, x minus 5. And so at this point, these are called factors. We're going to set each factor equal to 0. So we have x minus 2 is equal to 0. X minus 5 is equal to 0. So we add 2 to both sides. So we have x equals 2. We add 5 to both sides. So we know that x equals 5. We know that this is 0 and that's 0. Our last step is to check. So how do you check? Well, you want it to come out to be 0. So we have negative. We're going to check negative, and then we have 2 squared plus 7 times 2 minus 10. That's 4. Negative 4 plus 7 times 2 is 14 minus 10. And we want it to equal to 0. Negative 4 plus 14 is 10. 10 minus 10 is 0. So that does check. The next one is negative, and then we have 5 squared plus 7 times 5 minus 10 equals, and we're checking if it equals 0. 5 squared is 25, so it's negative 25, plus 7 times 5 is 35, minus 10, and we know that negative 25 plus 35 is 10, 10 minus 10 is 0, so it does check. We're doing number 13, and this is complex numbers, and we are going to simplify this. We're going to do the operation. So we have negative 4i times 4 minus 3i. So negative 4i times 4 is negative 16i. Negative 4 times negative 3i gives you positive 12i squared. Remember that I squared equals negative 1. So we have negative 16i plus 12 times negative 1. And we're going to write it in standard form. So we have negative 12 minus 16i. And that's our solution. Or that is our operation. 14, we're going to be applying the FOIL method. So we have 4 plus 6i times negative 5 plus 5i. So the FOIL method, 4 times negative 5 gives you negative 20. 4 times 5i gives you positive 20i. 6i times negative 5 gives you negative 30i. And then 6i times 5i gives you positive 30i squared. So we have negative 20 minus 10i, since it's 20i minus 30i, plus 30 times negative 1. Remember that I squared is equal to negative 1. So we have negative 20 minus 10i minus 30. So it should be negative 50 minus 10i. For number 15, we're going to apply the distributive property. We have 1 minus 5i times negative 4 plus 5i. So we apply the distributive property. 1 times negative 4 is negative 4. 1 times 5i, which I meant to say the FOIL method, 5i. Negative 5i times negative 4 gives you positive 20i. And then we have negative 5i times 5 gives you negative 25i squared. So we have negative 4 plus 25i minus 25 times negative 1. So we have negative 4 plus 25i plus 25, since negative 25 times negative 1 is 25. 25 minus 1 is 21 plus 25i. In this problem, we're going to apply the FOIL method. So we have 2 plus 2i, 3 plus 5i. 2 times 3 is 6. 2 times 3 is 6. 2 times 5i is 10i. 2i times 3 gives you 6i. And then 2i times 5 gives you 10i squared. So we have 6 plus 16i plus 10 times negative 1. So we have 6 plus 16i minus 10. 6 minus 10 gives you negative 4 plus 16i. For number 19, it says approximate the intervals which the function is increasing or decreasing. What I went ahead and did is I went ahead and broke this up into kind of regions, and I want you to notice on the far left we have negative infinity, on the far right we have positive infinity, and in between negative infinity and negative 3 it's decreasing. You see that blue? And then of course it transitions at negative 3, whatever this point is, and then it starts increasing all the way up to 3 and this point, which is 1.2, I think, or something like that, you estimate. And then it starts decreasing again. So we're looking at the increasing interval. And we only have one area that's increasing. It starts increasing at x equal 3, negative 3, and it increases all the way to x equal 3. Remember that the endpoints is a state of transition, so they're not increasing or decreasing, it's transitioning. Decreasing interval, there's two parts that it's decreasing, and you notice in the blue. So from reading it from left to right, we know it's increasing from negative infinity up to negative 3. Of course, it's transitioning. At that point, it's increasing, so we're going to jump. So we're going to use union. And then once again, when it starts at x equal 3, after, it's going to be decreasing. And it's going to be decreasing all the way to infinity. So I went ahead and broke it up into areas, like I told you, decreasing, increasing, and decreasing. We notice that we read it from left to right. The graph decreases from negative infinity up to negative 3. We don't include those endpoints on the interval. And then it starts increasing from negative 3 to 3. That's the green part. And then once again, it starts decreasing from 3 to infinity. This is a parabola. And for number 20, it's asking, it's wanting to know the decreasing interval. And we notice that we're getting only a snapshot of the graph, but we know that it's decreasing here. It's decreasing, and then it kind of starts, it stops at that point, which is negative 1, negative 4, and it transitions. Now it's going to continue to increase. And that's why I have two areas or two regions. This is describing the increasing interval, and this describes a decreasing interval. So now we have to write it mathematically. Remember, it is not an ordered pair. We're talking about an interval. So this right here is negative 1. This is x equals negative 1. Remember that. That's x equals negative 1. So we want to know when it's increasing. Well, it starts increasing at negative 1, but not, it doesn't start at negative 1. It starts after negative 1, and then it goes on forever, so it goes on to infinity. Decreasing, when we're reading it from left to right, we notice that when we're coming from negative infinity, you notice that the graph is decreasing. So after negative infinity, all the way as you approach negative 1, we notice that the graph is decreasing. Even though the arrow is pointing up, when you read it from left to right, you notice that the graph is decreasing. So the decreasing intervals from negative infinity to negative 1. This part of the review has to do with function operations, and it's telling you to do g minus f of x. So what you're going to do is you're going to subtract. So you've got to write in the correct order. Negative x plus 1 minus x cubed plus x squared. Remember that this part is g of x, and this part is f of x. Okay. So once you've done that and it's correct, then you can go ahead and you can eliminate the parentheses, except for the second one. I'm going to show you why. You have negative x plus 1. Remember, you have to distribute the negative 1. Negative 1 times x cubed, negative x cubed. Negative 1 times x squared gives you negative x squared. And of course, you want to write it in the correct order, the standard form. You always start with the highest exponent. So it's negative x cubed minus x squared minus x plus 1. when you have G times F, or that little dot F, that little dot times F, that means to multiply. So we have X plus 3 times negative 2x cubed minus 5x squared. So this part, once again, is G, and this part is F. So we're multiplying. So go ahead and do the FOIL method. X times negative 2x cubed, negative 2x to the 4th. X times negative 5x squared, negative 5x to the 3rd. 3 times negative 2x squared gives you negative 6x cubed. And then 3 times negative 5 gives you negative 15x squared. And then you try to see if you can simplify. In this case, there's 2 terms that you can combine. Negative 5x cubed, negative 6x cubed. So you get negative 11x cubed minus 15x squared. So we're going to go ahead and multiply G times F. And so we're going to multiply G times F of N. So we know that G is negative 4 and plus 3. And we know that F is N minus 3. So negative 4N times N gives you, you're going to do the FOIL method, negative 4N squared. Negative 4N times negative 3 gives you positive 12N. You multiply 3 times N, so you have 3N. And then 3N times negative 3 gives you negative 9. That's it, negative 9. So now you combine like terms, negative 4N squared plus 15N minus 9. Now we will do composition of functions. So we have G H of X. That's what it means. G, and your input is H of X. Okay. So we have G, and the input will be H of X. So I'm going to go ahead and try to color coordinate here. So we have H of X. So this is H of X. So let's use 3x minus 5. So we're going to use the G function. But wherever you see an X, that will be the input. This right here will be the input. That's the input. So you have 2, and then you have input minus 1. That is the input. In this case, it's 3x minus 5. Apply the distributive property. 2 times 3x gives you 6x. 2 times negative 5 gives you negative 10 minus 1. So at the end, the composition will be 6x minus 11. That will be G of H of X. And this is composition. So we're doing composition. So we have H of G of X. So we have H of G of X. In this case, G of X is X minus 2. So we have G of X as our input, and G of X is right here. We have X minus 2. And then our outer function, that's going to take the input. This will take the input. So we have negative 2 parentheses X minus 2 plus 2. remember that this was the input, x minus 2, and it was the input into function h. So we're going to go ahead and apply the distributive property. Negative 2x, negative 2 times negative 2 is positive 4, plus 2. So h of g of x will be equal to negative 2x plus 6. That will be h of g of x. We're going to go ahead and do f We're going to do f of g of n. So we have f, and then our input is g of n. In this case, it's 4n plus 2. So let me go ahead and use blue. We have 4n plus 2. That's g of n. And then our outer function will be f of n. So we're going to use function f as where we're going to input. So we have 4n plus 2, that's our input. Remember, n is our input, n is our input, plus, this is squared, 4n plus 2. So this is where we had our input. Okay, so I'm going to go ahead and do this on the side. We have 4n plus 2 raised to the second power gives you 4n plus 2 times 4n plus 2. I'm going to apply the distributive property. 4n times 4n gives you 16n squared. 4n times 2 gives you 8n. 2 times 4n gives you 8n. And then 2 times 2 gives you 4. So we have 16n squared plus 16n plus 4. So that's where it's going to go into here. Okay? So I'm going to go ahead and erase this right here and make it. So we have 16n squared plus 16n plus 4 plus 4n plus 2. I'm going to go ahead and take off the parentheses since I don't need them. Now I'm going to combine like terms. So I have 16n squared, 16n plus 4n gives you 20n, that's plus. And then 4 plus 2 gives you 6. I went ahead and did some selected problems from the review, and I'm actually going to send it to you out early. Please review this video and then work out some of the other problems on your own. Thank you.